Hey,
Hello.
hi. All right, let's wait. You can go ahead, mute yourself there. All right, we got one more friend over here. Hello, Ingun. Let's wait a few more minutes and we will start promptly, okay? We do need to have our IXL accounts ready, but towards the end of the lesson today, we will need it, okay? If you need to use a restroom real quick, make sure you use this time. Okay, well, maybe we'll just start. Our friends can join while we're working through our today's lesson. I hope everybody's doing great today. This is our second day, and second day we are going to continue with the same topic of fraction. Fraction tomorrow coming, we will be moving on to decimals and then combine them. Okay. All right. Give me just thumbs up if you were able to do your homework assigned to work from yesterday. Were you able to check them out? Yeah, you remember the little reaction buttons down on the bottom? You can just click those. Yeah, nice job. How about you, Zaya? You see there, yeah? Nice job. Yes. All right. So I am glad that you were able to go through your signed work. They are assigned as homework, but I am not going to be grading your work. If you feel like that work was a little bit too light for you, you can go up a grade level. You can do that. Okay. So use your account as you wish. You can use them with different grade levels. You can actually go in between math and English as well. Okay. All right. So today we are going to have the same shared screen right over here. Let's see. There we go. So just like yesterday, I will be looking at my separate screen over here. So in the camera, you're probably going to see me looking sideways, but I see you guys, okay? I see everyone. And if you have any questions, you can leave it in the chat or you can just raise your hand with the reaction button as well. All right. So today is our second day, and we are going to continue with the fractions. And today, our main topic or theme is fractions behave like numbers. So, yesterday we talked about fractions are numbers because they are numbers, they have values. So, you can compare them and you can order them from the least to the greatest or greatest to the least, right? And sometimes comparing different numbers, especially if it's not whole number, it makes it really difficult to picture and order them. So therefore, we use different strategies. Sometimes our teachers tell us to draw a slice of pizza or fraction bars, like a little tape that we did yesterday. Sometimes our drawings are not really clear enough, and we kind of just go down the rabbit hole of just drawing, trying to make sense of our own reasoning. So, therefore, there is another strategy that we looked at yesterday. That was the benchmark strategy. So benchmark strategy was what? You are going to use numbers that you absolutely know what they mean and what they stand for. Like zero. Zero means there is nothing there. One is a one whole. Any fraction, you can turn it into a whole if your numerator and denominator, two numbers are exactly the same. Like 3 over 3, 5 over 5 or 8 over 8. That will be one whole. So yesterday we talked about this strategy called what? Benchmark strategy. So today we are going to continue with the same theme, but not just to compare them, we are going to estimate before solving. We're going to do operations. So mathematical operations, we have four main operations, right? You can add. What else can you do? You can add numbers. What else?
Subtract.
You can subtract. That's another operation. What else?
Multiply.
Yep, great. And one more left.
Divide.
Right, nice job. So we can make all those four operations with fractions as well. We can use whole numbers and we can do the same operations with fractions. So we're going to go over fractions with operations. So instead of jumping to all kinds of procedures, first you probably heard keep, change, flip when you're dividing, right? So instead of going through all these rules and then procedures right away, we are going to look at can we estimate and then can we kind of have a mental math of thinking what my answer might or might not turn out to be. Okay, so that's the first thing what we will be doing. And then the second thing, let me put it into present there. And here we go. That was estimate before solving. And then secondly, we will decide if the answer we get makes sense or not. So we know, did we get it right? You know? Uh, and we are going to explain our thinking. So you probably starting to see the pattern here. We're not just gonna get the right or wrong answer and move on. We are trying to use the different, for example, for us, it's a benchmark strategy, right? Use a benchmark strategy and can we explain our thinking? That's the main theme for us this whole week. Okay. Now, lastly, we will be able to, or we will see some examples of spotting common mistakes. So there are many mistakes can occur. Mistakes are nothing really bad. We can actually learn a lot from our mistakes. That's how we actually learn and then prevent to make the same mistake over and over again. All right. So this is what we will be doing. And for today, here's our first question. Which fraction is larger? Take a moment, take a look at it. Remember the annotation tool on the bottom? You can use that and you can circle whichever one do you think is the larger fraction. All right. So I see a couple of our friends. Oh, third one. Nice job. We have three different answers. Well, two different. We have two options. It's okay. You can leave your answer option there. So if you see that your answer option was not correct, it's okay. All right. So we need to understand why it was not the right answer. So our benchmarks yesterday we talked about, you can look at the zero. Which one of these two fractions is the closest or closer one to zero? Which one is closer to 1? Or right in the middle, which is it? Half. Which one is the halfway point? So that's what you will be using to compare. Okay. So 1 over 2 is what again? That's exactly halfway mark, right? So only thing we need to think about right now is compared to this halfway point, is the 3/4, is it bigger or smaller? Is it more than a half or less than a half?
More.
Yeah, it's more than a half. How do we know that? If I ask you, hey, go ahead, prove it. Then you can say, hey, you know what? There is a four equal parts. Half of 4 will be 2, right? And but then they said 3 out of 4. 3 is more than a 2. That means what? Our correct answer will be this way. Our Who is ahead of me? All right. Our correct answer is 3/4 is a larger fraction. Okay, that is correct. Now, let's take a look at this second one. Now, it is titled Notice and Wonder, and then don't solve it. Okay, without solving it, can you tell me one thing? What do you wonder? What is different now? We're not just comparing two fractions anymore.
Where
We are adding, yeah. So you notice that, hey, you know what? We're not comparing that anymore. There's no actual question. If there were going to be a question, maybe Ms. Knudsen is going to ask, what is the answer to this addition, right? Why do we call it addition? Because there is an operation. That operation happened to be an addition, okay? All right, that's what we notice. What do you wonder? Is there something that you're wondering? Do you wonder what the answer might be? Yeah, yeah. All right. Some of you probably start working on your paper right away, or some of you are trying to make a mental math, right? So let's talk about the answer then. I wonder what the answer is going to be. I wonder if the answer is going to be more than one or less than one. What do you think?
more
More than one, okay. Do we agree? Do we all wondering if it is going to be more than one? Or some of us are also wondering, maybe it is less than one. Okay, so let's see how it is actually going to be turned out. Um, Here we go. Now, we are going to estimate. That's the same addition problem that we saw previously. Now, they gave us two hints. Okay, now looking at this problem, 3/4 is almost one. You told me that is the closest to one, right? Larger one. That's correct. And 1/2 is a half of one. Those two things we know for sure, absolutely. So after knowing that, which one do you think the answer is going to be? Should the answer be less than one, about one, or greater than one? Greater than one, greater than one. Okay, so all of us are thinking answer is going to be greater than one. Now we're going to be asked, how do you know? How do you know the answer is going to be greater than one?
I know that the answer is greater than one because uh 3/4 is more than a half. So and 1/2 is half.
Hmm. And when you add them together, what do you get? Half and a half will make
Whole.
one whole. So if 3/4 is already more than half, so we're adding something that is more than half and a half, it's definitely gonna be what? More than a whole, right? Great, that's a great logic. All right, let's see this problem slightly different. Where should the answer go? Yesterday we worked with what? Number line, right? If fractions are number, then we should have a number sense of is it more or less? If it is more or less than a 1 or a 0.5, where can we place them on a number line? So let's see. Where do you think the answer is going to be? Oh, what do you think? You guys can go ahead. For your answer, you can shade it. Let's see. Okay. Whole thing. Whole thing. Okay. All right, whole thing. All right, nice. This one was actually kind of, I should not say really, but kind of easy example, right? So what happened to the amount? Did it get bigger or did it get smaller?
Bigger.
It got bigger. So when we add numbers, what do you see? Your answer or the original given value gets greater, right? So it's getting bigger. So if we started off with one fourth, our answer definitely should be, I'm trying to get different color than you guys used. So we started off with what? One fourth. And we are adding three fourths. So we will add one fourth, one more fourth, and one more fourth. So this amount is what we added on, right? Okay. So after we do the addition, we have four fourths, which is a one whole, 4/4. So addition, we all should be good because we are moving on to sixth grade. Our youngest ones are moving on to sixth grade. But if we were not sure about it, this is what it is. Okay. Um, all right. You guys can take your marks. It's okay. How about we are subtracting? Subtraction makes numbers what? Smaller. Hmm. What about fractions? If you're subtracting fractions, what would happen?
They, they, they become smaller.
It will also become smaller. Subtraction is just that. There is no surprise. It is just getting smaller, right? So let's take a look at this. This is our subtraction problem. Okay, let's see. Should the answer be bigger or smaller? How would you show it on a fraction bar like this? Okay, the answer will be 2/4, which is exactly half of it. Okay, good. And there's my third person. Okay, great. So we all agree on the answer, but let's take a look at it. Let me go ahead, work it step by step. Okay, let's say I was a student. My starting point was 3/4. Three out of these four bars I color. Ugh, kind of going out of color. There you go. But then I'm taking away one of them. I am going to take away one of them. So the subtraction is what? That is an indication of taking away. So I will go, oh, why is my eraser not working? There you go. I'm going to take away one of it. Only one of it being taken away is going to give me what? Only two left. So this is one, this is two, this is 3/4. Now out of 3/4, I will be taking one away. That's that. What's left is 2/4. 2/4 is exactly the half. So I'm pretty sure you guys are thinking, oh, come on, Miss Knudsen, this is something super easy. We all know it. So we'll get there. Okay. Our next problem here. How about multiplication? It says multiplication surprise. So there is a surprise. If you are a fraction multiplication master, that is great. If not, think to yourself, if fraction addition makes it bigger, right? Greater. And fraction subtraction makes it smaller or less. How about multiplication? What is the surprise about it? What do you think? Okay, someone says it should get smaller. And the actual question there is what? Should multiplication make numbers bigger? Okay, bigger. All right. I still have one more person. What is my third person thinking? What do you think? Bigger, smaller, not sure about it? Still thinking? Okay, so let me rephrase it. Instead of just a multiplication, we're working with what? Um, Fraction. So we have 1/2 being multiplied by 1/2. But then if you think multiplication is supposed to make it even bigger, right? More than just addition. Uh, some of us are thinking, hey, multiplication should make it bigger. How about 1/2 times 1/2? What do you think? It should still be 1/2, okay? Okay, 1/2. One more person. Okay, so let's see. We have two, three people, and then some of us are thinking it is going to be 1/2. Let's see what exactly happens when we multiply fraction. Okay, so 1/4, somebody must have done the calculation. So if we only get to talk about correct or incorrectness, right? We are not going to be able to really figure out what just happened. We're supposed to get bigger number because that's what happens. If I say 2 times 2, it is going to be 4. It gets bigger. If I say 2 plus 2, it's also 4. It's getting bigger. It's supposed to increase. But when it comes to multiplication with fractions, it doesn't make it any bigger. It actually makes it smaller. Okay, so the reason for that comes, let's see, we can take a look at this. Reason for that, it is going to be our bar. I am not going to use a pre-drawn bar right here. This is one of the richest concept in math, especially going into middle school. It helps. If you're multiplying by a fraction, you're actually dividing. You're actually making it smaller. Our answer gets smaller. So let me try my best to draw two equal parts. Okay. I'm gonna go nice and big here. Da-da-da, and go one more. And complete this rectangle all the way, almost there. That's our one whole. Okay. So our first fraction is what? 1/2. That is 1/2. Okay, so we divided this one whole into two equal parts. So that matches with our denominator. Let me change my color here. And our fraction actually is talking about 1/2. So we actually looking at what? This part, just one, right? Now, we are going to multiply by a 1/2 again. So we're going to take 1/2 of this shaded area. So it's not talking about one of the shaded area. It's a 1/2. That actually tells us what? We need to divide it into two equal parts again. Gonna divide this into two equal parts. Good. Now, out of those two equal parts, they were shaded already. I am going to take one of them. Ooh, see that? So, did it get bigger or smaller? It got smaller, right? Compared to 1/2, now we have a half of a half. That's a small. Also, if you take a look at the whole thing, how we started, we can do the same thing. Half of this half is like that. Now we have one, two, three, four equal parts. So four equal parts. Total number of equal parts, that is what? Our denominator. That's the denominator, which is the number on the bottom. Out of that four sections, we are taking only one of them. So our correct answer here is what? 1/4. And actually, the question for us was, will the multiplication make the answer bigger or smaller? And compared to 1/2, 1/4 is smaller. So the surprise, when it comes to a surprise, when you're multiplying by a fraction, it actually makes numbers smaller. Okay, so we gotta remember that. We are not going to work with the division just yet. There is a whole set of rules, another thing there. So we're going to stop right here for today. Now, what is our big takeaway today? Is fractions are numbers, yes. Therefore, they can be what? All number operations, mathematical operations we do with whole numbers. We can also, operations can be done with fractions. We can add fractions, we can subtract fractions, we can multiply and divide fractions. Now, big one for us today is what? Multiplication has a surprise when it comes to multiplying by fraction. It doesn't make the original number or the given value bigger. It makes it actually smaller because our fraction is we taking the part of the whole, part of the whole. Okay. Now, so let me see. I'm going to call on someone. Zaya. When I multiply by a fraction, does that make number bigger or smaller?
Smaller.
Smaller, yeah. So our example is here. We started with 1/2 and we ended up with 1/4. Smaller. Let's see. Ingun, when we multiply by a fraction, does our value get greater or lesser?
Lesser.
It gets lesser. That's another way to say it is getting smaller, right? All right, our third person is Max. Max, when we are multiplying by fraction, does the original given value get reduced or does it get increased?
Increased.
Increased will be what? We are increasing, making it go up, up, up. It's getting higher, bigger. Okay, that's another way of saying what your answer is getting bigger, your answer is getting greater and increased. So if we are saying, hey, we started off with the 1/2 right here, right? And we multiply with another fraction, and our answer ended up being smaller or lesser than a 1/2. That is another way of saying being reduced. So this vocab, these words, they go with our work here. Let me write it out here. Words that can go with it. Small. Oops. Oop. Huh. Okay, I guess we are moving on. Not quite yet. I do not want to move on just yet. Let me select it right here. There you go. All right. So we moved on from 1/2 to 1/4. That is an indication of our answer here. 1/4 is gotten what? Smaller. That's another way of saying it is less now. You have less. Another way to say small and less or going down is what? It's reduced. All right. So this math vocab, these words are very important because most of the time your middle school materials, your textbooks or tests or teachers, they're not going to talk about is it getting bigger or is it getting smaller? They will be saying, hey, choose the greater value or which one is the reduced version of 1/2. So knowing your math vocab is very important. Okay. So how many different ways do we know how to say something is getting smaller? Smaller, lesser, reduced, going down. Okay, so let's just stop at four different ways. On the other hand, we can tell, oh, it's getting bigger, greater, going up, or increased. Okay, so we will practice using this vocab over and over again. All right. Now, let's see that next slide that is trying to pop up real quick. Now, which does not belong here? So we did this exercise yesterday, so we know how it works. There's no wrong answer as long as you can prove it and defend your answer. Okay, you can come up with a very complicated, sophisticated reason, or you can be saying as simple as, oh, no other answer has this number. Something simple, okay? So I'm gonna give you guys a couple minutes. Try to come up with reasons for all four of them, why they are not the one, okay? So try your best. Try to come up with reasons for all four. Okay, I'm seeing some patterns here. Um, Many of us, all of us actually agree on the 0.5. And I'm pretty sure we came up with the same reasons there. And one half looks like one person came up with the reason why it could be the answer that does not belong there. Okay. Remember, as long as you can defend your choice, there is no wrong answer. There can be multiple correct answers. Okay. So while we're thinking about these four options, since we all came up with the reason for 0.5. Let's start with that. And since there are only four of us, let's just make sure we all get to be heard. Okay. So we all going to take turns. So here's the trick. You guys are already all almost middle schoolers. Here is the trick. When your teacher asks for volunteers, always volunteer right away because you're the first one to get to explain and describe something you're thinking. It usually gets a little bit more complicated, but if you like the challenge, sit back, listen to everybody else's reasonings, and then you can justify your answer a different way also. Okay, so there's a pros and cons in both ways. Now, how about this time I am going to start with Max. And Max is going to give us a reason why Max thinks that 0.5 is not the answer or it doesn't belong here. Okay. And then after Max, I'm going to have Ingung and then Zaya. But your answer or your reason can't be the same. Okay. So while Max is giving us the reason, and Ingun should come up with different reason, and Zaya should come up with different reason. Let's take that challenge, okay? So I'm gonna give you another 1 minute. So that means you should come up with at least two more reasons why 0.5 is not the answer it belongs here, okay? All right, take a minute. Okay, I think we had enough time. Let's try. Okay, so go ahead, Max. What is your reason for 0.5 does not belong here?
I think 0.5 doesn't belong here because all of them are like different ways to represent like 0.5.
But not exactly as a decimal, right? The way
Yeah.
they're written is different. Okay, great. All right, next is Ingun. What is your reason for 0.5 does not belong here?
Uh, 0.5 is a decimal, so it doesn't have a numerator or a denominator.
Great, because 0.5, the way it's written, it does not have what? Numerator and a denominator specifically written out. Okay, great. How about you, Zaya? What is your reason for 0.5 does not belong here?
It's because 0.5 is the only number with the zero and no other one has zero.
Nice. Okay. I can say the same thing for number five too, huh? Oh, this is the only one has number five used in the writing. No other ones have five. So that's great. So you can go as simple as that, or you can actually show all kinds of drawings, make it really complicated. You can do that. All right. Now we're gonna do the same thing with let's see, nobody's picking half. That's 1/2. Let's see that last, okay? How about for this one, 2/4? We're gonna go move on to that one, but we're gonna go the opposite direction, okay? So this time Zaya is going to be the first one to give us the reason, and then we will have Max, and then we will have Ingun. Okay, go ahead, Zaya. What is your reason for 2/4 does not belong here?
Um, 2/4 is the only one with the two on the numerator.
Great. Okay. Next is Max. What is your reason?
I think 2/4 doesn't belong here because all of the others are half, but 2/4 is different.
Okay, can you explain what do you mean by that?
Because all the rest has like one tooth, and the other one also has one tooth, but the other 2/4 is the same as one. Like it's the same one as 1/2. Because if you double those two numbers, it's 2/4.
Great. All right. So let me rephrase it. Max's reason here is 2/4 is also saying 1/2, but it's not using 1/2 as a writing, but it's actually double the numerator and then double the denominator, but it's the same value written differently. Is that right?
Yes.
Yes, good. All right. Ingo, you're the last one. What is your reason for 2/4 does not belong here?
It has a denominator of 4.
Yeah, that's the only one that is written as a fraction and also use a different digit as a denominator, right? All right, now let's move on to this one on the bottom. 1/2 times 1/2. What is your reason that this one doesn't belong here? So our order this time is Ingun goes first, then Zaya, then Max.
I think uh, 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 1.5 times 1.5 doesn't belong there because uh, it's the only one that like equals 1/4.
Okay, when we get the answer to this multiplication, we get 1/4. So the final answer, final value is 1/4, and no other value shows that. Good. All right. That's a really good answer there. Next.
I think it's different because it's the only one with the multiplication symbol.
Yeah, this is the only one with the multiplication symbol. Also, only one with the operations showing, right? So that's a good observation there. All right, last one is Max.
Basically, when you multiply 1/2 with a 1/2, the result is like 1/4. And the other threes are basically 1/2. So it's basically 0.5. So it's the same thing.
Okay, so if I want to be really picky, I'm gonna say, hey, that sounds pretty identical to Ingun's reasoning. Ingun said, final answer to 1/2 times 1/2 is going to be 1/4. No other option shows 1/4, right? Can you come up with another reason?
That was the only reason I was thinking of.
Okay, all right, that's fine too. So, we can only do observation based on how they're written, which is very basic, right? Oh, this is looking like. And then we can make observation and also compare the value, which one is greater, which one is lesser, right? And then also we can now jump into, hey, if there is an operation involved, what is the final value going to be? Right? So now we're taking it a little bit of a step further. Now, our last one. There's there's one option there. Somebody picked it this time. Previously, no one was picking 1/2 as the one that does not belong here. So I'm gonna go in order. Zaya is first, Max is next, and Ingun is the last one. Why do you think, or what is your reason that 1/2 does not belong here?
I think it is because 1/2 is the only one as the final value as 1/2, showing 1/2, like showing it
Okay.
as the final value, not 0.5.
Are you talking about, okay, I'm gonna try to understand it. Are you talking about the final value or are you talking about the way they are written?
The final value.
Okay. Can someone give a different answer or try to explain to Zaya why or why not her reason makes sense? What do you think? Ingun and Max? Can you guys explain to Zaya and I if her answer actually makes sense, her reasoning, or not? And what would be your reason for that? Okay, so Zaya said 1/2, which is 1/2 right here, right? This is the only one with the final answer that says 1/2. But how about 0.5? Is that also half?
Yeah.
Yeah, so they kind of same, right? If we're talking about which half, the first half or the second half, that doesn't really get shown either way. So that's not a question. So they both are talking about half of something. How about 2/4? Is it 2 half of a 4, Zaya?
Yeah.
Yeah. So if 2 is half of a 4, 2/4 also is talking about something that's been halved, right? So these three, they all are talking about or showing half. So I am not going to agree with your reason just yet, unless you want to word it slightly differently and you can defend it. Okay, so let's move on. I forgot the order I gave you guys. So Zaya was first, and was it Ingun and then Max? Or you guys just can go.
It was just me.
Okay, go ahead.
1/2 is the only fraction that is fully simplified.
Nice. So, Max here, simplified. So this is the simplest term of a fraction. You can show half of 8, you can show half of 10, half of million, however you want it, right? Decimal or fraction, you can show it. But the 1/2 or 1/2 is the simplest form of that value. We will get to that when we get to fraction operations, but we're gonna leave it there right now. If some of us are sixth grade completed or closer to being exposed to that simplifying fractions, that's great. Okay, that's a very good observation. That's the simplest form. All right, one more person. What is the reason for 1/2 does not belong here?
I think 1/2 doesn't belong here because it's the only number only fraction that has a denominator of 2.
Okay, yeah. If we are just looking at the fractions that are written here, denominator is 2, denominator is 4, and then we got fractions here. I guess technically we can say, hey, this is just not just a fraction, actually is fraction operations. So I guess we can cancel that out, right? Other than that, compared to the fraction, just the single fraction given, compared to these two, this is the only one with number 2 or digit 2 as a denominator. Okay, good. So if we had maybe 10 person in this class, we might have come up with what? 10 different reasons. Some of them might really click and make us really think and wonder. Some of them maybe saying, oh, that's a kind of funny way to look at it, right? There's no absolute wrong or correct answer. We can justify it, and that's the important part. All right. Now, for us here, another exercise for us, you guys can take your marks there. I see your marks stay there. Maybe tomorrow I will set it differently. I can erase it. All right. There's error in this work. There was a student, and the student says 1/8 plus 1/2 equals 4/8. Is the student correct or not? Why or why not?
No, they're not correct because 3/8 plus 1/2 equals 7/8. Because 1/2 equals 4/8.
Okay, great. All right, so we have a friend who says, hey, this student is incorrect. Okay, and the reason is the final answer would have been what? 7/8. Any other reason or any other way you could explain it? How about we draw a comparison? How about we compare 3/8 here and 1/2. 1/2. So the idea of denominator, I see. Yeah, go ahead. If you are going to miss coming days, right? If you're going to miss part of the class, it's okay. You can just join later. If you're running late, that's fine. It's better than missing the whole class. Or if you have to leave a little bit earlier, that's okay. You can just leave me a chat and say, hey, I gotta leave a little bit early. You can ask for the link and you can watch the video later. Or after each class, your parents are receiving email with the suggested classwork or homework. Okay, so you can continue that. So Zaya, go ahead. You can go ahead. Now, I am looking at the 1/2 here. 1/2 here is we are going to make the denominator same. If it were 8, half of 8 is 4. That was a great explanation there. So 4/8, 4/8 is a half. So we're technically, what are we adding? We are adding 3/4 and 4/4. So we have 3 plus 4, that is 7, and it is correct. Our final answer would have been 7/8 or 7/8. And student made a mistake. All right, that's where student went wrong. But what do you think the student was thinking about? Do you think this student made a careless error there, careless mistake, was just not paying attention? Or do you think that student was thinking a certain way? What do you think the student was thinking?
I think the student was thinking that 1, 2 equal, 1/2 equaled 1/8.
Could be, yeah, 1/8, and then just added the numerators and kept the denominator. That could be what the student was thinking, right? So if we add the numerators only, we have 3 plus 1, and we would get 4/8. That's a great way to think. Sometimes our friends or sometimes ourselves, we ask for help from our friends or teachers, right? And then they ask you, okay, show me what you were thinking or show me what you were working. Then we should be able to explain. And as teachers, we will be finding your mistake, but not just saying, oh, you're wrong or you're correct and move on. To see, hey, what might you be thinking so we can correct that thinking or help you to think the right way. Okay. So when we add numbers, we just, for example, 3 plus 1, you adding two whole numbers, right? It's easy. You get 4. But when it comes to a fraction, you don't just add the fraction, keep the denominator. There's only reason you can keep the denominator the same because we have here, for example, we have 8 here, right? 8 is the denominator of the first fraction right here. I'm gonna just highlight it, 8. And we turn the second fraction's denominator into 8. That's when you keep the denominator the same. It doesn't change. But to begin with, our denominator for first fraction was 8, and then second fraction was half. So you can't really keep the denominator the same. So we call these additional fractions with the same denominator, okay, or like denominator. So we're gonna do a little group jam there, what we did yesterday in IXL. But your IXL group jam is going to be a couple different steps. We will work with fractions with like denominators. When it says like, that means your denominators are the same. And if you're adding or subtracting, you keep the denominator the same. But if we have unlike or different denominators, first step is to make them the same. Okay, so keep that in mind. That is exactly what this student's error was. Now let's take a look at one last thing before we move on to IXL. So which answer is impossible? Instead of being asked for the correct answer, we're being asked for which answer is impossible. Absolutely wrong answer. What do you think? Okay, A. Okay, Max, what do you think?
I'm still thinking.
Okay.
I don't know why, but my pencil isn't working, but I say it's A and C.
Okay, so A and C. A is a common answer there between two of you. So let's just start with A. Why 1/4 is the answer we absolutely should not be getting?
Because 3/8 without adding is already bigger than 1/4. I mean
Yeah, great.
3/4.
When you add like two positive numbers, uh, it has to be greater.
That's right. So our operation to begin with, it is addition. So like we said before, we took a look at it. We all were on the same page, and it is great. When you adding positive integers or positive fractions, even any positive values, they supposed to be what? Increasing, getting greater, right? So 1/4 is already smaller than our original value. So 1/4 should absolutely not be our answer. So C was also mentioned. Max, what was your reason for C, which is 5/8? Cannot be answered at all.
Because you always have to like cross multiplication.
Okay, what do you mean by that?
Like when you put two fractions, the bottom numbers always have to be the same number, so you gotta add it. That's how you can add it in yeah.
Okay. Ingun, let us know if you agree or disagree, or if you have any questions in this section, okay? Um, Let me see. I am pretty sure Max is talking about this. Let's say I have 3/4 plus 1/2, and this was given by my teacher, and I'm asked to add them. And Max said, hey, I'm supposed to get my denominator the same, right? That means we're supposed to be looking at common factors to going down and list common multiples going up, right? So we will get to details tomorrow as well, but that's exactly how we will get there. When we get to 4 and 2, if we are checking this against the answer that has a denominator of 8, let's just say I decided to have my denominator to be 8. I'm going to run out of space here. Let me just use it a little bit better. All right. So I decided to make my denominator 8. Now, that means how would you make 4 into 8? I will multiply this by 2. And your denominator and numerator is supposed to increase or decrease by the same scale, right? So if I multiply on the bottom by 2, I have to multiply by 2 on the top. So 4 times 2 made it 8. Yay! And then 3 times 2 would have made it 6. And I'm still adding, right? Now that means I have to turn this 2 into 8 as well, so that I can have same denominator. So in order to make this 2 into an 8, I have to multiply it or make it 4 times bigger. Do the same to the numerator, make that 4 times bigger. Now 2 times 4 is 8. And yay, I got it the same. But 1 times 4 is a 4. That means I would have ended up with what? 10/8. So it's like Yeah, I got my denominator to be the same and I got 8, but somehow my numerator did not scale up the same way. So that's the difference. So when we're adding or subtracting fractions, our first step is what? To make the denominators the same here. But if you are scaling this 4 up to 8 right here, it needs to be scaled or the increased by the same times. This is multiplied by 2, multiplied by 2 on the top also. Multiply by 4, multiply by 4 on the top also. Okay, now once our denominators are the same, then all we gotta do is carry out the operation, which is 6 plus 4 is 10. Maybe some of us might have seen our teachers writing it like this. Especially kids come from Mongolia, they write it just like that. Instead of writing it and looking at them as a separate, two separate fractions still, we have the idea of, hey, I'm going to get one answer, right? So I'm going to have the denominator the same. It's just 8. That means on the top, I have what? 6 plus, that's the operation we have, 4. And all we gotta do is what? Carry out that addition, and we have the same answer. But when it comes to the denominator, we already combined it, made it the same number. So easy. Easy on the eye, okay? So is that what you were talking about, Max? Making the number the same? That's what you said?
Yeah.
Okay, great. What do you think about this part, Ingun? Was it okay making the denominator the same?
Um, yeah.
Kind of? Okay, good. So with your grade level, we should be moving up to scaling up, scaling down. Another way of making what? Same without changing the value. It still is a 3/4 of something. We just made it what? 6 over 8. 6 is also 3 parts of the 4 equal part of 8. Okay, so we will see that. Now, any questions about the idea of scaling up, scaling down? We good? Okay.
Yes.
All right. One thing to keep in mind, when you are scaling up or down a fraction, you have to do the same to the both numbers, to your denominator and to the numerator. If you multiply by 2 here, it has to be done on the top as well. Okay. All right. That in mind, we are good over here. And we will be transitioning in, moving on to our IXL. I'm gonna give you guys a couple minutes to log into your or switch onto your IXL screen. Go ahead. Okay, I'm going to switch my screen here. If you logged into your IXL or if you are logging in now, you should be prompted to join Group Jam. So we did that yesterday. A little prompt on the top of your screen should be coming up. And right now we have only 2 kids. It should be a quick one. All right. I am still waiting for Ingun. Ingun, are you able to join us in the IXL?
The group jam isn't showing up.
Okay. Did I mix you up with someone else? Your full name is Ingun Tux.
Yeah.
Yeah, I did pick you up there. Let's see.
Wait, no, in my name it does have a space.
Um, However your name was put in, it should be okay. Your account, were you able to join yesterday? You were okay, right?
Yeah.
Yeah, I should not have other group here. Let me just check. Let me get out of this screen here.
Try joining out and joining back in.
Sure, yes, go ahead.
Wait, oh, you sent it to my other account.
Okay, so let me get this.
Naman
Yeah, I see. Where did it go?
нөгөө жилийн эрхт нулимс танаас авсан тэр л юм байна.
Tinbejin.
Чи
M. This should be
Ah,
it. Okay. Now let's see.
баярлалаа.
Mhm. All right. Are you able to see it now?
Wait. Yeah.
All right, nice job. Okay, so I am going to give you a minute to take a look at it, but while you're looking at this same question, our friend Max already answered, and then great job, got it correct. I'm pretty sure you guys are very familiar with IXL, how the explanation, if you get it incorrect, you should be still scrolling down and see what went wrong and what could you make it better or different. Moving on. Okay. So take a look at this question. This one is a subtraction. So if we are comfortable with the procedures, we can just dive right into how we're supposed to subtract. First thing is what? To make the denominators the same. I have denominator of 12 and a 10. I can make them the same number. That's what I can do. Or we can be starting to think, hey, what my answer might look like. More than 0, less than 1, more than 1, right? A little bit of estimation. Like it or not, we are going to be taking quizzes in classes. We're going to be taking tests moving on. So we are going to be doing some kind of timed tasks in the future, right? So not everything should deserve sitting down and writing it out piece by piece. Sometimes it just takes what, a little bit of quick mental math, okay? So for that reason, this benchmark strategy is a great thing to do. But if you are super comfortable with the procedures, just write it out quick enough. That's it. So that takes the guessing out of the way. So however you're going to work with these exercises, it's up to you. Okay. So for this question's sake, it says estimate the difference using benchmark. So our benchmarks are given 0. Are we going to have a 0? No, it's definitely not going to be 0. If you have a 0, exact same value should be subtracted. I should have had 11 over 12 minus 11 over 12. That would have been a 0. If I started off with something that is less than a 0, less than a 1, and I'm subtracting, will I ever get a greater number? No. So 1 should not be my answer. So it is at best should be what? Half. That's a one way to work a problem like this. Okay. So we don't really have to write everything out. And there is a little reasoning how to solve step by step how it is going to be. This is a little introduction to benchmark strategy. Okay. Let's see the next question. Let's just try same one. Since there are only 3 of us, we will have plenty of time to go around. So for this one, should my answer be greater or less than my original? What do you guys think?
Greater.
Greater, because we're adding, right? Addition means your value is starting, which is your starting value is 1 over 6. 1 over 6 should be getting greater, but how much greater? I don't know it yet. So let's do a little bit of estimating here. Okay, so 1 over 6 is definitely not close to 0, definitely not close to 1. All right, but somewhere around maybe less than a half. And then 4 over 9, what is a half of a 9?
4.5.
Half of a 9 would have been a 4.5. So 4 over 9 is already what? It is less than a half. So if we are adding something that is a less than a half and a less than a half, it could come up to a half exactly. Will it ever come up to be a whole? Now, if we only have 2 parts, both of them needs to be half and half. Together, that will be what? 1 whole. Or less than a half, more than a half, possibly can be a whole. But if it is a less than a half and a less than a half, never gonna make it to what? Whole, right? So in that mathematical sense, we can say, hey, it is never gonna be a whole or not even a greater than a whole. And I wanna say the answer should be a half. That's an estimation. But if I want to be precise and say, hey, you know what? My teacher says, show your work. Then I have to show my work. What do? I have 1 over 6 and a plus 4 over 9. So my denominators are different. My first goal is to make my denominators the same. I'm just going to go with the easiest way to come up with the common denominator. Common means the same, right? The way to come up with your common denominator is to multiply the denominators. That's the easiest way to come up. We will look at some other strategies tomorrow. So 6 times 9 is what? 54. That is my denominator. If I am multiplying 6 times 9, I also have to multiply the top 1 times 9. If I'm multiplying 9 times 6, I have to multiply by 6 on a top as well to make them exactly scaled up the same way, right? So my 1 times 9 is going to be 9 over 54 plus 4 times 6 is 24 over 54. Now I have two fractions and both of them have the same denominator. Now I have to just add the numerators. 9 plus 24 is 33. 33 over 54. Is it a one whole? That's definitely not a one whole. At the best estimation, it will be about half. So it kind of proves my answer. I clicked my answer and I showed my work to my teacher. It is what about, meaning I can say this is about, not equal to, right? About what? One half. That's the estimation. Okay, so we can take a look at this. One half. And then estimation, their explanation goes the same way. We are going to round the 1/6. 1 is much less than 6, and we can say, hey, this is closer to 0. So the benchmark idea comes in again. Okay, so let's take a look at something else. I would suggest let's stay on the same level, or would you like to try a harder example?
Harder.
Hard.
Try a harder one? Okay, let's see.
Yeah.
Yesterday we saw, right? We went all the way to level 7 out of 7. It wasn't that much of a harder problem. It was just a little bit different. All right, so just looking at this, what is your estimate? Are we going to end up with the 0?
No.
No.
If we had the minus 5 over 11 minus 5 over 11, that would have been a 0. Are we going to end up with 1?
Mm,
No, we
no.
started our starting point, which is the first fraction. Starting value is already what? Less than a 1. If it was going to be one whole, it would have been what? 11 over 11. But not only that, we are subtracting. So when you're subtracting, your value is supposed to decrease, right? So this is not the answer. This is not the answer. Only option left for us is the estimation of about 1/2. All right, you guys want to go harder or stay the same level? I think we have just the same level or easier. We have two options left, seems like.
Same
Do the
level.
same level? Okay. How about we take turns? Do you want to be called on? There are no options for you guys. There are only two of you, so it's either Max or Ingun, or you can just volunteer. It's okay. So, what do you want to say? Do you want to say, hey, the possible answer is, or absolutely, this cannot be the answer?
I don't think it can't. It cannot be. It can't be 1.
Okay. What is your reason for that?
Cause 11, 12 and 7/8 added is more than 1.
Yeah, it is more than one. So exactly 1 is not really an answer. But wait a minute, I have 1 and a 1.5, but they are estimation, right? So they're technically not talking about it's going to be exactly 1. But how about if I ask you slightly differently? Is the 11 over 12, is it really close to 1 or kind of close to 1?
It's close.
It's really close, almost 1 maybe, right? So this one is almost 1. This one is also almost 1. So it's definitely way more than just a 1, right? So we have two options left. 1.5-ish or almost 2.
I think it's 2.
Yeah, let's try two. Okay, so we're gonna say, hey, they both are pretty close to be one. So if both are added together, definitely gonna pass the halfway mark. So closer to two whole. Let's see. All right, that estimation is great. So we could have just made the denominators exactly the same and find the answer, right? So let's try that. Next one. Now, our answer is going to be reducing 6 out of 10. Now, let's go ahead. Instead of actually just estimating, we can do the estimation and let's check our work by showing our work. Okay, so I'm gonna give you guys a minute or less than that. Go ahead, make your estimation. Okay, so Ingun already answered. Um, what was your estimation?
Half.
Half? Yes,
Yep.
oh, I see. Max got it too. So our estimation was half. If we were asked by our teacher to show our work, what would you do? What is your first step here?
Already, like I already see the 6/10 minus 1/9. Like 6/10 is like a little bit above half,
Mm-hmm,
and so I just and 1/9 is uh close to zero,
mm-hmm.
and the uh almost half minus close to zero is like still closest to 1/2.
There you go. Nice one. Yeah, that's a really clear reasoning. So it was a little bit over half, and then we are subtracting something that is almost a zero. It takes away that a little bit, right? So we are getting somewhere close to half-ish. So if we were asked to show our work, what is our first step? We need to make something the same. How do we get that number?
We multiply the bottom, like the
Yep.
denominator,
Yeah, great. What number will I get?
90.
90. That's great. All right. If we have two fractions being subtracted and we made the denominators the same, now it's 90. How about my numerators? What do I have to do? If these two are being multiplied, I'm going to scale up or multiply the tops as well, right? So this 10 is being multiplied by 9. That means I will multiply the numerator of that fraction by 9 also. It's like the same thing. 10 times 9, 6 times 9. If I multiply 9 by a 10, I have to multiply the top, which is the numerator, by 10 also. So it is same as 9 times 10, 1 times 10. So my first one is going to be 54. And next one is going to be 10. Ooh, this is really close. You can see, huh? 54 minus 10 is 44. And 44 over 90. So what is the half of a 90, guys?
Uh, oh, uh,
What is it?
it's 45.
Yay, great. So do you see how close your estimation was? You were right. So you guys got this absolutely correct. If you were just asked to estimate, easy. And if you were asked to show your work or prove it, you can prove it. And you can tell, hey, how close I was. Exactly halfway mark is what, 45 over 90. And the answer we got it shows what? It's 44, just one away, right? One out of 90 away. So it is really close to be exactly half. So that's a great estimation, guys. I know it is 5:30. Let's just do one more and then we will call it a day. Okay. How about this one? Okay. Let's see. Max, can you explain your estimation, reasoning, or the logic behind how did you make your estimation?
So basically I did the same thing. It's like 10 times 6 and then it's 60 and then your 60 is the denominator, so it's basically 6 times 1 is 6. 10 times 5 is 50. And then if you look closer and then you get, yeah, I forgot, wait, yeah. And then the number is 1. So, wait, no.
So the estimation I see, or you all can see my screen too. So you both got it correct. And I'm really great. That is a good way to get actual answer. And then you can even
Mhm.
stop without finishing the addition problem, right? Unless you ask to show your work. And then another way to explain, you guys explained it before in a previous problem was this one is almost being what?
Mhm.
Closer to 0. And then a second fraction is closer to 1. And then very small number, almost 1 together will come up to estimated close to what 1-ish, right?
Yeah.
So when it says estimate, that is telling you to guess it, what it might be. It does not mean what exactly it is going to be. So it is okay if you say it's almost a little bit over, or it exactly ends up being one even better, right? Okay. So I am going to call it a day for now. And just like yesterday, I will send your parents email with links to homework. This is just an extension for today's lesson. If you would like to do further than what I send you, it's great. I am going to send Max slightly different ones. I will add a third and a fourth option for you, or you can just do a similar topic on your own. But since you guys just finished the school year, I really encourage you guys try the next level. Okay, if you just finished fifth grade and moving on to sixth grade, you're probably exposed to sixth grade materials already. Okay, so try the sixth grade and then try the seventh grade as well. All right. Yes, Max.
I just wanted to ask, what time are you gonna send like the assignment?
Oh, it should have been like auto set. Did it come late yesterday?
I don't know. I did it at like night.
Oh, okay. All right. Maybe I can send it to start be sent, schedule it to be sent around the same time we start. I set it scheduled around the same time we finish, which is 5:30, 5:35-ish. It should be in your inbox. If you want to right away to start, you see this little three oh, right here. Number 9, J and R. This is the exercise we're doing right now. So you can just type it in the search here. number 9, J, and R. So this is always going to be your first work. What we end our day with is your first work to complete at home. Okay, so you can start with that, and I can absolutely can change that schedule time. Your homework assignments should be posted at the same time when we start. I just did not want you guys to worry about doing the work while we are just working here. Okay, you want me
Okay.
to set it a little bit earlier? Yeah.
No. Like
No?
I
It doesn't really matter. Okay, all right.
Yeah.
I'll just set it. So I'm just gonna say it. Just make sure not to worry about. I'm not asking you to complete it before starting the class. It's just there. Okay, you can even change it. You can do more. You can do less. It's up to you. But I encourage you to do if you're seventh grade, try it at eighth grade once. It's not too far off. It might be giving you a little bit of minute lesson. You can check it out. If you're comfortable with it, work it. It's good. Okay. All right. Do you have any other questions for today? No, we're good. Okay. So have a good night, guys. Nice seeing you, and see you guys tomorrow. Bye.
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 Bye.